Hey everybody, it's Mr. Ray here with our next lesson in grade 11 university math. We are working in the trigonometry unit, and today's lesson is going to be pretty quick. It's something called reciprocal trigonometric ratios. It sounds a lot more complicated than it really is. So we already know some trigonometric ratios. The sine, cosine, and tangent ratios are trigonometric ratios. Those are the three ratios that you'll probably use 99% of the time. But we have three other ratios for trigonometry, which are they're the reciprocal ratios of sine, cos, and tan. Okay. Now sine, cos, and tan. Another name for them are, and I think we saw this last lesson, we also call those the primary trig ratios, which means they're the main ones. Okay, and these ones we're going to work on today are called, well, they're reciprocal, but we also call them secondary trig ratios. These are the ones that are less common, but they're there. So you have to understand what they are. You probably won't have to use them much, but probably the only time you'll use them is when you see equations you have to solve that already have them in. But if you're starting from scratch with a triangle problem, you probably won't use these. So let's talk about what they are. So the first thing is just to know what reciprocal is. So if you multiply a number with its reciprocal, you always get 1. And I know that's not the best definition of reciprocal. But if you have a fraction, say 3 over 4, the reciprocal of 3 over 4 is 4 over 3. You just flip the numerator and the denominator. So reciprocal is just a math name for flipped. Okay, but it has to be a fraction. So what happens if you have 2? What's the reciprocal of 2? Well, anytime you have an integer, what you want to do is put that number over 1. So, for example, 2 is the same as 2 over 1. Now, if I wanted to take the reciprocal of 2 over 1, well, that's more obvious. The reciprocal is 1 over 2. Okay? So, just as easy as if you had to take the reciprocal of a fraction, all you have to do is put the integer over 1 and then treat it like a fraction and flip it. Okay, so that's what reciprocal means. So here's our definitions. This is probably the most important part. The reciprocal trig ratios are, here are the names, the official names: cosecant, secant, and cotangent. And they are the reciprocals of sine, cosine, and tangent in that order. Okay, so what does that mean? So here's our first reciprocal ratio. The cosecant trig ratio is defined as cosecant theta, whatever angle you're looking at, is equal to hypotenuse over opposite. Now, we've seen hypotenuse and opposite used before, but that was the sine ratio with the flipped version. Sine is opposite over hypotenuse. This is hypotenuse over opposite. So this ratio, we call this the reciprocal ratio for sine. So I could write cosecant theta as 1 over sine theta. Okay, and we'll use this a little later on. So similarly, secant theta is defined as hypotenuse over adjacent, which seems familiar because that's the flipped version of what cos is. So we can write secant theta as 1 over cos theta. Okay, and then the last one, cotangent, is defined as, and you notice the lettering we're using, it's always the first 3 letters of, well, except for this one, SC. We can't use the first 3 letters of cosecant because that's the same, it would be the same as cos. So we do the first 3, I guess, consonants instead. CSC is cosecant, SEC for secant, COT for cotangent. Okay, cotangent is the reciprocal of tan, because cotan is adjacent over opposite, where tan is opposite over adjacent. So it's really the original three ratios, just the flipped or the reciprocal versions of them. Okay, so this example here, just show how we do this. If we have this triangle ABC and we've got these three side lengths of each side, we want to determine the 6 trig ratios for angle A and then the 6 trig ratios for angle B. Okay, so that's a total of 12. So once we get going, it's not going to be a problem. So let's start. We'll start with angle A. So temporarily put something there. I'm not going to write the side names because I'm going to have to change them when I go over to B. So if I'm looking at the ratio for sine of A, okay, I know sine is opposite over hypotenuse. So if I'm looking for opposite, that's 3 over 5. Okay, I would do cosine A is adjacent over hypotenuse. So adjacent side for A is 4 and hypotenuse is 5, so 4 over 5. And then tan of A is opposite over adjacent, which is 3 over 4. Okay, so before we do B, let's do the other three, the new ratios for angle A. So remember the reciprocal of sine was cosecant. So let's do that one besides sine. So cosecant of A. Now this ratio is the reciprocal. So it's h over O, which is the reciprocal of that, of course, which is 5 over 3. So you can see how sine A and cosecant A are related. They're just reciprocal answers. Okay, if we change, go to the next one. So the reciprocal ratio for cosine is secant. So secant of A, this is h over A. You can get this from the definitions up here if you want. And h over A is just the flip version of that, 5 over 4. And then finally, cotan of A is adjacent over opposite, which is 4 over 3. Okay, so now we have our primary trig ratios for angle A, our secondary trig ratios, or our reciprocal trig ratios for angle A. We do the exact same thing for B now. So remember, when we go to B, our opposite and adjacent sides change, because now for B, this side would be the opposite, this side would be adjacent, which was different from angle A. Okay, so sine B, opposite over hypotenuse, but this time, so this time it's 4 over 5, because the opposite side is 4, the hypotenuse is 5. Then we'll do cosine of B, which is adjacent over hypotenuse. Adjacent side would be 3 over 5. And then finally, tan of B is opposite over adjacent, which is 4 over 3. Okay, let's do the reciprocal. So the reciprocal of sine is cosecant, so cosecant B. Everything is flipped from this, h over O, which is 5 over 4. And then we have secant of angle B is hypotenuse over adjacent, flipped, which is 5 over 3. And finally, cotan of B is adjacent over adjacent over opposite, which is 3 over 4. Okay. Now, one way I remember how to remember which of these ratios relates to the original three. Well, the easiest one for me is tangent and cotangent. I mean, the names are very similar, so they kind of match up together. Tangent, cotangent. Now, the other four ratios, you notice I've got, sine and cos, they start with S and C. and the reciprocal, I've got secant and cosecant. So I've got an S and a C for both. And it would be really nice if we could match them up by letter. It would be nice if sine and secant were reciprocal, but they're not. So we kind of have to think opposite. The S and the C's match up together, not the S with the S and the C with the C. So that's how I remember which are the reciprocal ratios for the sine and the cos. It's always the other letter that it starts with. Okay. So we got a couple fairly quick little equations here that we're going to solve using reciprocal trig ratios. So we're given that the cosecant of angle A is equal to 8. So our job is to figure out what is that angle. Okay, now you probably notice on your calculator there are no such thing as cosecant, secant, and cotangent buttons. So you can't just do cosecant inverse. There's no button for that either. So what we always have to do is change these reciprocal ratios into the original sine, cos, or tan. Okay, so when I see cosecant A, I know cosecant A is 1 over sine A. So that's always what I change it to. Cosecant A is equal to 1 over sine A. And I don't flip this. This is equal to this, so I have to put an 8 here. But I'm going to put it as a fraction. So 8 over 1. Okay, same value, and this is also the same value. I haven't done anything other than change the way I've written it. Okay, now I want to write this in, I really want to have sine A equals something, and I can do that if I take the reciprocal of both of these. So in other words, I'm going to flip both of these fractions. When I do that, the equation is still going to be equal. So when I take the reciprocal of that, I get sine A. And when I take the reciprocal of 8 over 1, I get 1 over 8. Okay? And now I've got the equation written in the form that I can actually use the calculator for. But before I use the calculator, if I want to get the angle, I have to take the sine inverse of both sides. So angle A is going to be equal to the sine inverse of 1/8. And this is something you can definitely do on your calculator. I'm going to get angle A is equal to, if I round it, it's going to be 7 degrees. Okay, so you saw the strategy here. If you have a secondary trig ratio, in other words, the reciprocal ratios, what we want to do is change them into the sine, cos, or tan equivalent, and then use our calculator with those. Okay. So here we have secant B equals 5 over 2. So again, can't solve this with a calculator. So we're going to change remember the related trig ratio for secant is going to be cos. So secant B is the same as 1 over cos B. And our fraction, it's already a fraction, so I don't have to put it over 1, is 5 over 2. And now we're going to flip both sides. So when we flip it, we get cos B is equal to 2 over 5. And again, now I can take the cos inverse of both sides to get angle B is equal to cos inverse 2 over 5. And that works out to angle B is 66 degrees. Okay, last one, of course, is cotan, just to get used to it. So cotan is the reciprocal ratio for tan. So I'm going to write cotan C as 1 over tan C. And that's equal to 5/16. It's already a fraction, so I don't have to put a 1 under it. And then I'm going to flip it again. So I get tan C is equal to 16 over 5. Therefore, angle C is equal to the tan inverse of 16 over 5. Do that on the calculator. We get angle C is equal to 73 degrees. So hopefully that gives you the hang of how would we solve something, an equation that's got one of these reciprocal ratios in. we always change it to one of the primary ratios. So we can use our calculator. Okay, so one more question here. It says determine two angles between 0 and 360 that have a cosecant, I probably should say ratio, of -2. So this is saying cosecant of the angle is equal to 2. So I can actually create an equation. So theta will be the angle or angles I'm looking for. Cosecant theta equals -2. But of course I can't use my calculator with cosecant. I'm going to change it to the reciprocal of cosecant, which is 1 over sine theta. And again, I want to change this to, well, I'm not changing it. I want to have this as a fraction, so that's -2 over 1. And now I'm going to flip both sides, so I get sine theta equals, now we could write it as 1 over -2, but it doesn't really matter where the negative sign is, so I'll leave it on the top, but switch the numbers. So -1/2. Okay, now if I do the sine inverse on both sides, theta is equal to sine inverse of -1. Sorry, I want to write inverse, I wrote theta. Sine inverse of -1/2. And it's important to keep the negative there, because if you dropped it, you'll get the wrong answer. When I do this on the calculator, I get theta equals -30 degrees, which is unfortunate because it's asking me for angles between 0 and 360, which this isn't. But we just did a lesson on coterminal angles. So if I, well, let's just see what that looks like. So if I put this on my XY grid with my circle, okay, -30 degrees is going clockwise 30 degrees. So -30 degrees is right there. So this would be -30. Now, if I want to turn that into, I want to keep my terminal arm exactly where it is, but I want to rewrite that angle as something between 0 and 360. So all I do is I rotate around counterclockwise back to where I began. So I'm basically adding 360 degrees to -30. And when I do that, I get 330 degrees. So that angle definitely will work. If you do cosecant of, well, if you could do it on a calculator, if you did sine of 330 degrees, you're going to get -1/2 for sure. If you could do this on a calculator, if you could do cosecant on a calculator, cosecant of 330 degrees would be -2. Now, it did ask for two angles between 0 and 360. So we learned a little bit about this on the last lesson. We learned that for a given trig ratio, there's always going to be two angles that get you that. So we didn't really talk about this way of solving, but when you got the sine ratio, basically saying the sine of an angle is -1/2, remember sine theta is equal to y. And we did that last. So it's basically saying the y value is -1/2. So if I actually drew y equals -1/2 on here, it would intersect at that point on the circle, which would give us that 330 degree angle, or -30, whichever way you want to call it. But it actually intersects the circle at another spot over here, which is the mirror image of this angle. So both of these angles have a sine value, sine ratio of -1/2. So it's just a matter of figuring out, well, what angle is that? And here's where we can use our symmetry. So this is perfectly symmetrical across the y-axis. So if that, if that's a 30 degree angle there, well, so is this. Okay. So if I'm calculating what that angle is, I could say, well, it's 30 degrees past this angle here, which I know That angle there is 180. So 180 plus 30 is 210. So that's my second angle. So I can make my conclusion here. Therefore, two angles with a cosecant ratio of -2, that was the original question, are 210 degrees. That's the one we just got over here, because I should write 210 over here, 330 over here. 210 degrees and 330 degrees. And again, you could test this out. You could find, well, what's the sine of 210? You'll get -1/2 on your calculator. So that's a way you can test your answers, to plug it back into the original question or the original equation. We couldn't, like I said, you couldn't plug it into here because we don't have a button for cosecant. We have to convert it into a sine equation and then plug it into there. Okay, so that gives you a quick view on what these reciprocal trig ratios are all about. They're basically, it's just the same ratios as before, but the reciprocal or flip versions of the ones we know and love. But like I said at the beginning, how often will you use these? Well, you probably won't. If you're given a triangle to find a missing side or angle, or you're creating something from a word problem, you'll never use the secondary ratios. You'll always use the sine, cosine, tan to solve. The only time you'll see these come up, cosecant, secant, and cotan, is when you're given an equation, something like this, where they ask you to solve for the angle. So you have to understand what these reciprocal ratios are and how you deal with them when you're trying to solve. Okay, so that's it for today. Thank you for joining me, and we'll see you on the next lesson. Take care.